Hello, and welcome to my presentation. My name is Timothy Mulcahy, and today we're going to be talking about probably the most interesting networking protocol that you've never heard of before. It's called Reticulum, and it is a sovereign communication network that I think you'll find very interesting. Before we talk about the how, what, and why of Reticulum, let me paint a little picture for you. Driving in a remote area, you have an issue with your car, it breaks down. You stop, don't know how to fix it. You have no cell phone coverage in the area, and there's a storm coming your way. Now, what are your options? Normally, you're in a bad place here. You'd have to wait for somebody to come along. You'd have to try and walk somewhere. You'd have to try and get a signal. You could be waiting for hours. You could be in a lot of trouble. I want you to think about this scenario, and we'll talk in the end about how Reticulum could save you in a case like this. So you're probably asking yourself, well, what is Reticulum? Reticulum is a completely decentralized open source networking protocol. It can operate between any devices, completely hardware agnostic, and between any communication protocols. So you can communicate from a radio to a cell phone. You can communicate across 5G. You can communicate across the internet. You can communicate across radio signals, any radio signals, be they Bluetooth or long-range radio. It's completely decentralized, as I say, open source. You can develop on it, and it operates and can operate in extremely low bandwidth and very, very high latency environments. Before we get into the how Reticulum works and the technical details, we should discuss why Reticulum was invented or engineered, and what the founders of the network sort of call the philosophy or the Zen of Reticulum. There's sort of 10 points here. We'll go over each of these points. It will give you a clearer idea of how Reticulum is meant to be used and why it was invented in the first place, to have a truly decentralized, open source, and what I might call a free networking protocol. So Reticulum operates without any central control. In today's day and age, we often think of things being in the cloud and that things have to have a client-server model. And this isn't the case with Reticulum. The client-server model is no longer needed. There's no centralized server needed, no centralized routing tables needed. You can think of it as sort of like a blockchain as decentralized, but this is even more so than decentralization. This is what they would call uncentralizability, right? Reticulum is mathematically uncentralizable. So there's no privileged nodes, no central registry, there's no routing handled from a central location. Nothing has to travel to a server or to the quote unquote cloud, as we like to call it. There is no central control. So it's truly an uncentralizable network mathematically. There's no address to track a person by. There's no IP address used. There's no address needed. So there's no origin and destination to where you can track things. There's no tracking of where something came from. So you can't see where something's origin was. You can't see an address to where something's going. And this is a central theme to the Reticulum network itself. So completely uncentralizable, no central control at all. Much like we've become very used to the centralized model of sending things to the cloud, we've come to trust where our data goes. So if our data flows through Google or another ISP or a telecom company, we assume that our data is secure, right? But as we've seen so many times, data is not secure no matter where it is. And so trust is something that we take for granted now, but as we see throughout the news on a regular basis, that trust is not guaranteed. So the physics of trust itself sort of changes. Encryption becomes mandatory. It becomes a proof that we must have, just like it becomes a law, similar to how gravity is a law. It's not something we can work around. So this is baked into the system itself. So if our data, gets sent out and it gets routed through a hostile nation, or it gets routed through a company that's not going to protect our data, or if someone's spoofing an address, all of these things can happen. And with Reticulum, these things are no longer possible. It becomes a physical law that our data is secure no matter what. And another point about Reticulum is that we've become so very used to having very high bandwidth and having very little latency. Um, Not just the network itself, but even you can see this even in programming, right? The abstraction has become very high. We consume lots of memory. Where there's always more and more cache. With Reticulum itself, it needs to be able to operate in very low latency environments. So it's like switching from programming Python to programming in assembly language. As an analogy there. So we have Reticulum is able to operate at extremely low bandwidth, extreme high latency, and still able to get data across the network. In today's day and age, we have no say over how our data is trafficked through a network. We have no sovereignty over it at all. But Reticulum is a game changer here. It allows anyone, no matter of your status, to be able to have control over your network. You don't have to be an ISP owner or a billionaire in order to do it. Your identity isn't tied to an IP address. You have complete nomadic ability with Reticulum. Your identity is shielded and it can go with you anywhere. It's not tied to a MAC address or an IP address. It can wait for you on the network until you appear and you can be off it and message can still be sent to you. It's also a very ethical and moral based system. Safeguards are in place so that Reticulum cannot be used to harm other people or to be used in nefarious ways, which is something that large networks that we're forced to use do not have. Another very unique aspect and very useful aspect of Reticulum is its store and forward patterns. We're very used to if a connection drops, if we lose internet, if our cell phone coverage drops, whatever we're transmitting at the time, whatever we're sending, it gets lost in the ether. And with Reticulum, you don't have this problem, right? These nodes will be retain the data, store and forward it until that user comes online. So if a connection is dropped, if connectivity is lost, if there's some sort of an issue, data itself isn't lost. The data itself will be stored and forwarded amongst its nodes until the recipient of that data comes back online, they become available, and that data can be transmitted to them. And with many other protocols, we're very used to losing our data when that happens, as opposed to knowing that our message will be received by the end user no matter what with Reticulum. And now that we've discussed what Reticulum is and why the Reticulum network exists, let's discuss the details of how this works. First, we'll go over sort of a basic understanding of what works, and then we'll get into some more of the technical details of how the underpinnings of sort of the gears of Reticulum operate. So one of the first features of Reticulum is that it has universal connectivity. So we know that it can communicate across any communication type, Wi-Fi, cables, radios, Bluetooth, 5G, it doesn't matter. Reticulum is able to maintain connections no matter the type and no matter the hardware, completely hardware agnostic, as we talked as well. Um, and the protocol is very adaptive, so it can go in between all these connection types from node to node. It doesn't have to be over the same network for each node, so it can be different connection types, different communication protocols, very robust, flexible, adaptive, completely decentralized, and this allows for very resilient communication. Reticulum has what's called the multi-hop transport, completely dynamically. So the nodes dynamically configure routes without any global routing tables, which makes the network very adaptable. So nodes messages hop from node to node, and they learn these node paths by sort of listening to their neighbors, making these announcements, using the most efficient path at the time, dynamically changing them. Nodes consult sort of local tables upon packet arrival, to see what hop should be made next. And this way, these complex routing can be done seamlessly and also dynamically across media, across connection types, as we discussed already. So that multi-hop transport allows the packet to move throughout the network seamlessly because of this sort of multi-hop. So hop and hop. So with this multi-hop transport, nodes are able to overcome any barriers by traveling from node to node to get closer to their destination. Um, so if a device is out of range, it's able to get closer by relying on this hopping. Each relay goes to the next, overcoming these physical limitations in the way that the hopping is set up throughout the network. As we discussed before, it's completely decentralized. So we have no central authority. Each node in the network operates independently. The networks themselves are independent, and there's no single server, putting control over the networks itself. Each device is equal to all of its peers, and they work together to form these network functionality. And it also provides security, resiliency, and privacy by doing this, as the network node path can change as the network is completely dynamic. The other big feature of Reticulum is that encryption is by default. There's no extra process that's needed to put encryption. In fact, unencrypted data can be sent over the network itself. So automatic encryption, it maintains user confidence and safety. No matter what, everything is encrypted. Origin and destination are unknown in the network, so no one knows where something came from, and only they know the destination, not as an address, but as a user itself. So let's get into some more fine-grained details here of how this works. So that was sort of the overview, sort of how the devices are agnostic, how messages hop from node to node. There's no central control, and encryption is default and secure. So let's get into some more fine grain here about how this works itself. Let's take another good use case here. Let's take a look at this use case here. Imagine you're sending a text message to someone who's only a few feet away or in the same house as we see in this example. Instead of that message going from phone A, node A, to phone B, node B, that message might go from, on a normal network, would go from phone A and then through a big round trip network, right? It could go to a server, several servers, many servers, could go to a cell tower, could be sent all the way up to a satellite, back down to a cell tower, all the way to get to someone who may only be a few feet away. And as you can see, there could be lots of issues with this. Someone could intercept that data along the way. That data wastes all sorts of electricity, taking these huge round trip circuitous routes that it doesn't need to take when someone is only a few feet away. With the reticulum, you get rid of this, right? You can directly send a message to someone only a few feet away through many other routes that otherwise you'd have to take a big round trip route here, as we see in this example. And there could be many issues along the way. The message could be lost, it could be stolen, it could cause all sorts of security issues. And with Reticulum, we can get rid of all of that and have much more direct and secure messaging set up. In this slide, we can see some of the code that's used from the Reticulum manual here to create a transport packet. You can see it's very simple. We have a destination, a data, we can create a receipt. And this plays into universal connectivity for Reticulum, right? Device can have direct connectivity. Link types don't matter. So this transport's become universal. You could have a node, could be using Wi-Fi, using UDP and TCP sockets like we've been doing in many of our labs. You could have an Ethernet, that's running a local area network. You could have a radio signal. Each node is attaching transports. So it's interoperable across many different types of links. It works against very, very low bandwidth. So let's talk a little bit more about mesh routing, how this works. So if a destination is needed, Reticulum sends out a message trying to discover the path itself, right? And it's able to find sort of the optimal path doing this. So each node kind of acts as a router, and the messages hop between these nodes. This sort of dynamic mesh is formed this way. And the process of path discovery, we'll talk about here, is a pretty fascinating one. Um, so as we can see here on the left, sort of a diagram of how this deterministic path finding is done. So what it does is if a node wants to reach a destination, it sends out a path request. So this announcement is made. And you can see some of the steps here. So the destination sends this announcement. It's forwarded by transport nodes across the network. And to sort of prevent infinite loops, the nodes ignore any announcement that they already received. There's metric tracking. Nodes record which neighbors have sent them messages and the total hop count. It allows for building a routing table, the most efficient next hop for any destination. So this is done dynamically. And there are limits to how many hops can be sent for each path. Uh, the maximum is 128 hops, and then that packet will be discarded. This prevents sort of the infinite wandering and searching. And it keeps the bandwidth manageable. So you're only using a fraction of the total bandwidth. This prevents the network from being congested with sort of path discovery packets being sent out. And during this path discovery, those nodes, those packets themselves are not encrypted. So path discovery nodes are unencrypted nodes searching for the path, the optimal path, and they will do this dynamically. It prevents sort of this infinite loop from happening by limiting the number of hops that any one packet can take. Since Reticulum is meant to operate with very low bandwidth, the network will prioritize announcements to destinations that are closest to it in terms of the total number of hops. And this ensures that the connectivity remains very fast and reliable, even if the network is slow. If something needs to be retried, Reticulum will wait for a confirmation. The node listens for its neighbors to see if they're continuing to propagate that packet. It doesn't hear that the other nodes have propagated it with a higher hop count. It retries the transmission itself. And if the node receives a new announcement from the same destination, it will update its table. That way, it contains updated, data, and will replace any of the old versions of that data in the packet itself. So the reticulum network is able to sort of act recursively. That way, no single node has to know the entire network itself. Transport nodes can be transported to their neighbors, and a path can be resolved recursively by moving that packet to nodes that have a better network knowledge than the previous node that sent that packet. And also, this allows sort of a rapid convergence, as you'd say, on networks where bandwidth is low. Even very complex topologies using all 128 hops can have end-to-end connectivity usually in about 1 minute. As we mentioned before, there are no IP addresses in the Reticulum network. The network uses cryptographic hashes for addressing. So it looks for that destination as a cryptographic hash, not as an IP address, not as a destination, not as a MAC address. And this routing decisions are made by each node knowing the paths along them. This allows not just security, but resiliency, scalability, and complete and total decentralization, not relying on any large-scale centralized networking routing tables. So each destination has a unique public-private key, which ensures strong authentication and a secure network. Any forwarded nodes that travel along the path to their destination remain completely anonymous. They can't be read. They're encrypted by default. And this ensures that no intermediate nodes can get the information that's contained in that packet themselves. Old messages are completely secure. Origin is unknown. So if keys are later broken, the old messages are unable to be unencrypted, and their origin remains unknown no matter what. So now we know what the reticulum network is, why it exists, and how it operates. We can take a look at that scenario we talked about in the very beginning. Car broken down, middle of nowhere, bad weather could be coming, you're stuck, no cell service, no coverage. You're at the mercy of maybe walking to somewhere, hoping somebody comes by, continually trying to get cell coverage. This could be a very dangerous situation. But if you were running the reticulum network, you might be able to send a message out to a hiker, let's say 10 miles away. They are also running the reticulum network. They receive that message on their device. They don't know that they received it, but the device gets it. It then forwards that message on to, let's say, a ranger station another 12 or 15 miles away. That ranger station, it's run the reticulum network. It has internet access. That message gets sent out from their reticulum node on to whatever destination you sent it to. You may be sending that to a family member or a friend who can come and know your location. You might be sending it to emergency services who could come and help you, to a tow truck driver. Um, so if you just had a cell phone, you'd be out of luck. But running the reticulum network could, save your life. It could prevent you from having to spend the night out in the wild. And this goes to show you how powerful this network is, especially in environments like this. Very low bandwidth, very high latency, very dangerous situation to be in, and it could certainly, save someone's life. Um, and so, knowing that, I um, encourage everyone to get started with the reticulum network. At least read about it, discover it, make your own device. I'm currently working on a small scale reticulum network with a mesh-tastic radio that I've got set up. This is certainly a very powerful technology and networking protocol, which could have all sorts of use cases, especially in an emergency. So you can see here, you can read the Reticulum manual. It has lots of really good information, how to get started, how to set up your own network, devices that are already running this, apps that are already running this. So I thank you very much for listening to this presentation. I hope you found it useful, and I hope you get out and try this new networking protocol, which is very much needed and could potentially save someone's life. Thank you.